23. We have limit as x approaches 2 from either side, from 3x squared plus x minus 14 over x squared minus 4. First, I have to check. Why do I need to check? I always plug it in, because I don't know if it's an indeterminate case or if it's no hope. And then I'm looking for this. So when we plug in 2, I get 4 times 3 is 12. 12 plus 2 is 14. Minus 14 is 0. Yay! And when I plug in 2, I get 0. Which is the factor that I'm hoping to eliminate. One more thing. You cannot drop the limit operator ever till the last step when you plug it in. So the limit operator cannot disappear till the final step. You have to carry it with you till the moment you plug in and you're done. Please. Okay. Good, so then I write limit. As x approaches 2 from other side, what would you write immediately, blindly? What will you do at this point?
You write x minus 4 and x minus 4, I mean 2, sorry, on the bottom.
Exactly. So since I plugged in 2 and I got 0 over 0, and these are polynomials, I have to write my x minus 2, and I have to figure out the rest. Of course, the denominator is x plus 2, and the numerator will be what? 3 plus 7? 3x, right? 3x and to get plus 7. So if you have any doubts, let's check. 3x times 3 some x squared is 3x squared, and this is minus 6x, and this is positive 7x, and this is minus 14, and this is your x that you have. Of course, it has to work. Yay, and I'm getting rid of the culprit. That's the problem. Once I get rid of the problem, the limit exists. I may get rid of the problem, but if I have 2 the same here, the limit may still not exist. So that's what I'm saying, the limit might exist in those situations. And can anyone give us the final limit?
Is it 13 over 2?
Very good. 3 times 2 is 6 plus 7 is 13 divided by 4. Any questions? Any questions? Well, let's also look at the radical. See how we address that. Like, let's say, 28. And that's limit as x approaches 9. From 9 minus x and the square root of x minus 3. So let's plug in 9. What do we get at the top? We always have to start with that. What do we get at the top? Yes. Over. Good. Now, you could say that x minus 9 is the problem. I would agree. However, this is not a polynomial. This one is a polynomial. This one is not a polynomial. So I have 2 options. I can factor 9 minus x, and you could say you never showed that before. That's true. I never showed, and I never. We never really think in those terms that we can factor 9 minus x, but we can. And let me show you how. And you can say, no, I don't want to use this method, and we have an alternative. So 9 minus x, first of all, is not arranged in the correct order. This is the correct order, descending order. Then I don't like the fact that it has a negative leading coefficient. I will definitely pull it out. These steps, for me, it's up to you, but for me are mandatory. Arrange it in descending order and factor out the leading coefficient if it's negative. And there is a way of factoring this into the square root of x plus 3 and the square root of x minus 3. You may say, I don't want to do this, and if you don't want to continue with this factoring the numerator like that with minus blah blah, and of course you see the square root of x minus 3 will go away, then we have to rationalize. Rationalize the denominator. It's up to you. You say to me, I understand this, I've seen it before, or you can say, forget it, I want to rationalize. And you tell me which method to continue with. We want to rationalize, or we want to continue with factoring. And you tell me and I'll do it. Anyone? Any preference? No one wants to choose?
We try the rationalized one.
Very good. So then we will multiply. I'm going to use here multiplication by the square root of x plus 3 and the square root of x plus 3, which is the conjugate. This is called the conjugate of the square root of x minus 3. And where is my torture? My torture is here. Okay, here it is. So I have the square root of x plus 3 and the square root of x minus 3, and I will get x minus 9. The square root of x plus 3 times the square root of x minus 3, and I will get x minus 9. Okay then, so I copy the numerator, but I will copy it in the correct order. This is the correct order. And multiplied by the square root of x plus 3. Oops. Let me erase my page number and put it in a different spot because it's confusing here. Sorry about that. And the denominator is the square root of x minus 3 times the square root of x plus 3. Let me write it so you see it, because it's half on one page and half on the other. That's not right. That's not nice. Okay, so then this is the limit as x approaches 9. And now you can say, I know, this is what you must get rid of for sure. So negative x minus 9 and the square root of x plus 3. Everything divided by, of course, x minus 9. Yay! Done. Out. The square root of 9 is 3. 3 plus 3 is 6, with minus in front, negative 6. I'm looking at another radical situation, like let's say 36. And we have limit as x approaches 3 from the right of the square root of x squared minus 9. In all these limits from 31 to 36, we must find the domain of this function. Find domain first. Can anyone give us, how do I start to find the domain of this function? So this function is f of x equals the square root of x squared minus 9.
You get rid of the square roots.
Careful, this is not an equation, I cannot do that. I'm only trying to find the domain. So I have to write something, solve that something, and get the domain. What do I have to write? What do we know about square roots? What can I have here under the square root? What type of number? Or what type of numbers? What could this be? Say it again. What type of numbers? I don't need specific numbers, just tell me what type. We discussed that when we graphed them last week. What did we say? What can we put under the square root? What type of number? Numbers. What type of numbers we can put in there?
Any numbers like 1, 2.
So you're talking about positive numbers or 0. I agree. So then I have to solve this inequality. Solving this inequality will give us the domain of this function, and that's what we have to do. And this is a whole theory behind it. No, I cannot move 9 and take the square root. Please do not ever do that. So solving a quadratic inequality means study the sign. So let's see how we do this. So x squared minus 9 greater than or equal to 0 reduces to x plus 3, x minus 3 greater than or equal to 0. The first thing we did this semester. And now I will study the sign of this product. First factor is x plus 3. Of course, this is the variable in the problem. Second factor is x minus 3. However, I'm not interested in either one. I want the product. X can be anything. So now, I know that this is 0 at negative 3. Negative 3 will make this 0. And this one will be 0 at 3. These are the numbers, the only numbers I need in the table. So x plus 3 is 0. X minus 3 is 0 at 3. The product will be 0 if either is 0. And now I study the sign. I plug in negative 10, and this is a negative number. I plug in 3, and it's a positive number. I plug in negative 5, it's a negative number. After 0, I plug in 10, it's a positive number. Now, when I multiply a negative number by a negative number, what will be the sign of the outcome? Very good, awesome. When I multiply a positive number by a negative number, very good, and then when I multiply two positives. So then, now I'm asking myself, what sign will be greater than or equal to 0? Well, it has to be positive. For this and for this. So the domain of this function is negative infinity to negative 3 union 3 to infinity. Okay. Finally, I'm ready to answer this. 3 from the right. Is the function defined at 3 from the right? It is. So the answer will be 0. So limit as x approaches 3 from the right from the square root of x squared minus 9 is 0. What if I ask find the limit as x approaches 3 from the left of the square root of x squared minus 9? What would you say? Excellent. Of course, the function does not exist from the left of 3. Great job. Thank you.